Okay, so here we go. Gonna make a little video for you on how to do the sundial. Some things that you need are a ruler, a compass, some scissors, and a protractor. It would be very helpful if you had a manila folder like this because it's rigid. If you have something that you can use, cardboard, poster board, something a little bit tough, that would make life easier for you. But if all you can find is some paper, then you can use that as well. If you don't have one of these, that's going to be a problem. So maybe you want to get onto the internet and figure out how to make one, because you're going to need a protractor, and you should be able to divide it quite a few times. So try your best to find a protractor. And a compass, you can use anything to make a circle. You can use a coffee can or a coffee mug, rather. Any circle will do as long as it's a reasonable size. So first thing we're going to do here with my folders, we're going to cut it in half, giving you one 9 by 12 sheet. Size isn't really important, but I would say with this, the bigger the better. Cut off the tab, make it nice. And I recommend using a pencil and drawing very lightly when you do this, because you may decide you want to fix it. So here on the compass, we have markers. We have the 3-inch marker, and that would give you a 3-inch radius. So mark the center and figure out a good spot right in the center. You can even make it on the lower end, like down here, because we were going to use this part up here. So wherever you decide to do it, make sure that you mark the center point, because we're really going to need that in a few minutes. And then you take your compass and draw yourself a decent sized circle. I say 6 inches. It doesn't really matter though, because that's not the important part. The circle is the tool. So from there, we're going to make a horizontal line. Now, I'm sitting here, and if you're watching, you would look here. I'm going to make a horizontal line that goes from one end of the circle to the other, and it doesn't have to be perfect horizontal. It just has to be pretty close. And I'll go all the way across the paper with that, making sure that you go through your center dot. That's how you know that you are precise and that you are cutting your circle in half. This side over here is going to be 6 o'clock a.m. and this side over here is going to be 6 o'clock p.m. Now we take our protractor and we lay the center on the dot and make sure the base of the protractor is on the line you just drew. And from there, we're going to measure up to the 90. Now, if we take 6 a.m. and 6 p.m., then this must be 12 p.m., right? That's noon, and that makes sense because that's when the sun is going to be at its highest point. So from there, we are going to continue making our hours. We need to make 1 o'clock, 2 o'clock, 3, 4, 7, 8, 9, 10, 11. And then over here, we're going to do 1 p.m., 2, 3, 4, 5. In order to do that, we need to figure out exactly how many degrees we need to divide this into. So if we have 5 hours here and we divide 90 by 5, that's going to give us 15 degrees, if I did my math correctly. 15 degrees is how far the sun travels in an hour. That is true. That is what happens, more or less. We don't have to be totally precise here because it's just Spanish class, as I say. So every 15 degrees, we're going to mark it. So we mark 1 at 15, 1 at 30, 45, 60, 75. And if you did it correctly, you will have a perfect distance in between all the lines. To keep going, we can either continue going and continue counting, or we can start from the other side and do 15, 30, 45, 60, 75. Okay, so it's gonna look like that. You can do the numbers at the bottom, but that doesn't really matter. Now it's starting to look like a clock, right? Starting to look like a clock, only this is gonna be a 24-hour clock instead of a 12-hour clock. But the hours down here are gonna be dark hours, so our sundial doesn't care about it. Okay, so remember to keep your ruler on the center dot. Center dot over to 7 a.m. and draw a line straight out to the edge of your paper like that. And continue around, starting at the center dot, going through your mark that you made, 8 o'clock, 9 o'clock, 10, 11, 12, 1 p.m., 2 p.m., 3, 4, and 5. All right, now it's starting to look like something. Pretty neat shape, right? You can mark them, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5. Okay, so we are well on our way. Now, we need a way to measure what time it is based on the sun. And for that, we need to make a shadow. In order to make a shadow, we need a gnomon. The gnomon, G-N-O-M-O-N, is going to be the triangle that casts the shadow onto the sundial. In order to do that, we need to know a couple of things. First, we need to know the magnetic declination for Easton, Pennsylvania. We're going to need to position this in the right direction in order for it to work, and we need to know which way is true north. That means that this needs to point at the North Star. North Star will be a little bit off if we use a compass. So if you take your phone compass, it's not going to point at true north because of the magnetic pull of the Earth. So we need to figure out what the magnetic declination is. Now, I had a tough time finding this, so Google didn't work too well. It gave us Bethlehem, Tennessee, which gave us a bad number. So I'm just going to tell you right now, the magnetic declination for Easton, Pennsylvania is about 12 degrees negative. So we're going to write that down here. Magnetic declination, negative 12 degrees. I'll explain what we're going to do with that next week, but we need to have that information. The next thing, and probably the most important thing, is we need our latitude. So if you Google the latitude of Easton, Pennsylvania, you will come up with the number 40. Latitude, Easton, PA, is 40 degrees. Now that's going to be the angle that we have to make our gnomon. 40 degrees, if you want to understand what latitude lines mean, that is actually the angle that we are facing away from true north. So if you take the North Star, if you've ever looked at the North Star, and you take where we are on the globe, we are exactly 40 degrees away from the North Star. The North Pole would be 0 degrees, the equator would be 90 degrees, or vice versa. The North Pole would be 90 and the equator would be 0, because that would be facing the North Star perfectly. But we're on a 40-degree angle, and that's the angle that we have to make our gnomon. So now we're gonna take our other paper here, and remember that key number is 40, okay? So Here's where I wish I were more of a math teacher, but I'm gonna do the best I can. We are going to make a right triangle. So up here in the corner, if you just draw yourself a right triangle, remember that one angle is going to be 90 degrees, and then the other angle along the base is going to be 40 degrees. So we're gonna call this A, we're gonna call this B, and we're gonna call this C. And that doesn't really matter because we're gonna be drawing it. We don't need to determine what this angle is because it's gonna match up once we draw it with our ruler. But we need to know that this one is 90. We need to know that this one is 40. And then we need to come up with a length. Now, based on the size of the paper, I think a good length for our gnomon base is going to be 3 inches. So you take your ruler now and kind of right in the center of your paper, you make a line. Doesn't have to be perfectly flat. It just has to be 3 inches. Gonna make a dot here, gonna make a dot here. We're gonna call this one A, we're gonna call this one B. Okay, the next thing we can do is make our right angle. That's gonna be nice and simple. Now, we don't know how tall the leg is gonna be just yet. So we're just gonna put our center of our compass right on dot B. We're gonna make sure it's flat along the base and our leg will be 90 degrees. So we draw ourselves a nice long line. Like I said, we don't know where it's gonna terminate. It doesn't matter. As long as we have one angle and one side and another angle, we can use angle, side, angle to determine the other angle and the other lengths of the sides. That's why we do it. So what's the magic number again? The magic number is 40. We're gonna need to make a 40-degree angle right here. In order to do that, we take our protractor again, put it over here. This time, the center of the protractor goes on dot A. We have the base, and we go to 40 and mark. Now, we draw the line from A through the other line, and that'll be C. Doesn't matter what this angle is, we don't really care. Double check it to make sure that you got a good 40-degree angle, that you did it right, that you marked it in the right spot. Oh, look at that. I wasn't paying attention and I marked it on somewhere else. Oh wait, no, I did. Center point A, flat on B, and the measurement is 40 or 140. Okay, so that's what yours should look like. Now you can erase the extra parts. We don't need them anymore. And we just need to remember that this part goes flat on the paper, okay? So we'll label this bottom, and we'll go from there. Now, we're gonna fold this, okay? So very carefully, make sure you fold it along the hypotenuse, which is the important angle. That's gonna be the long one. Fold it along the hypotenuse. And try not to smear it because we're gonna try and make it pretty. But give it the best fold you can here. And now we're straight, okay? We're gonna need something to attach it to our sundial, so we're gonna draw a little rectangle. Underneath A and B, draw like a 1-inch rectangle. Doesn't have to be perfect. I'm not even gonna measure that. And then we're gonna cut along this line, and we're gonna throw this part away. Then we're gonna cut along this line here. We're gonna go throw this part away. And the final cut will be this little remaining triangle, and we'll throw all this part away, leaving us with our little gnomon triangle. Okay, so now we have the bottom. We're gonna fold each side up along the bottom edge. So we're gonna fold that rectangle we made. And fold it the other way. And then we're gonna open it up, kind of like half of a paper hat if you ever made one of them. It's gonna end up looking like that, okay? All right, now, remember which is the important side. The important angle is that 40-degree angle right there, the bottom of our gnomon. Now we come over here, and we're going to attach the angle that is 40 degrees to the bottom along the 6 a.m., 6 p.m. line. That's where it starts. And make sure that it is also lined up with 12 p.m. That's gonna be the important thing. Then we come over here, take our stapler or our tape, whatever we have available, and we're gonna make sure to staple it perfectly. Now this is the part that needs to be precise. It needs to start there and end on the 12. And it can get a little tricky. You may just want to use tape. Yeah, let's do that. Start with a piece of masking tape. And we'll tape that down there. And we'll tape that down there. Now you can leave the tape on if you want, but if you want to clean it up a little bit, you can now go in with your stapler and just keep double checking to make sure it's straight. Yep, that's not going to reach. That's not going to reach. That's not going to reach. I wish I had a bigger stapler. All right, so I guess we're leaving the tape on. Okay, but that's it. That's good. And you know, you can see now what you had to do. Use some Scotch tape. And we are done for now. We have our magnetic declination. We have our latitude, 40. We have our gnomon built. The gnomon starts at the bottom of the 6 a.m., 6 p.m., goes to the 12 noon mark. Okay, next time we're gonna add some more details to it. But we are finished for now. Feel free to start to decorate it, color it in, make it pretty. And don't forget, if you're at home, you got to take a picture of this and send it to me. All right. Have a great day, everyone. Contact me if you need any help. And we are also going to, I included instructions on the lesson, so you can always look at that. All right. Have a great day, guys.